This is the PowerPoint review continued, so this is the second video for that. So for this slide here, they're asking us to graph and find domain and range. So to graph, I want to put it into vertex form. So I'm going to add 2 to both sides. And then once I get into this form, I just need to find the vertex. So for my vertex, what affects the x is the 3. So I'm going to do the opposite, -3, because that will bring it back to 0. And then for the y, I'm going to use -2. So vertex is -3, -2. And then my stretch is the number multiply my radical, which in this case is 1. So that will give me my first 2 points, right? So point 1, point 2. So I'm going to go ahead and get that part. So -3, -2. And then for my stretch, I'm going to go up 1 over 1. And then I need 3 points though to accurately graph. So I'm going to go 4 units away from my vertex. So if my vertex is at -3, 4 units away, 1, 2, 3, 4 would be at 1. So then I'm going to evaluate my original equation for x equaling 1. So I'm going to do it just above it, just to kind of save a little bit of time. So instead of x, I'm going to use 1 because 1 is 4 away from my vertex. So 1 plus 3 and then -2. So then this is 4. So the square root of 4 is 2 and then -2 is 0. So when x is 1, my y value is 0. And then that gives me my graph. And so my domain is from left to right. So the farthest left the graph goes is to -3. And then it goes forever to the right, so from -3 to infinity. And then my range is from bottom to top, so the lowest the graph goes. Whoops. Got my little cattywampus here, aren't I? This is actually at -2. And I double checked that because I looked at my vertex, so I know I don't go below my vertex, so I don't go below -2. So -2 is the lowest, and then even though it doesn't look like it's going up forever, this graph slowly grows upwards, so it will go to positive infinity. So the lowest is -2 and the highest positive infinity. So for question number 2, put this in standard form. So I'm going to subtract 1 from both sides. Find my vertex, so I'm going to use -2 and +1. And then my stretch is the number multiplying my radical, so that would be -1. So I'm going to go left 2 and up 1. So from the origin, left 2, up 1. So there's my vertex, and I need 3 points though to graph. So my first point is always coming from my vertex, my second point from my stretch. So from my vertex, I'm going to go down 1 and then to the right 1. And then to find my third point, from my vertex at -2, I'm going to go to the right 4. So 1, 2, 3, 4. So I'm going to use x equals 2. So from here, I'm going to replace x with 2. And again, every time I find my third point, I don't have to do the over 4 trick. I can actually use any number I want as long as I can do the square root of it. So I'm going to choose x equals 2. So I have y equals 1 minus replace x with 2. So 1 minus the square root of 4. So y equals -1. So 4, square root of 4 is 2, 1 minus 2 is -1. So at 2, I'm going to go to -1. So right here. And I should have a decreasing, right, a negative radical because my stretch was negative. So domain and range. So how far left I go? So I go to the left, -2, forever to the right, so positive infinity. So my domain is -2 to infinity. So the range is bottom to top, and I can see that I top out at +1, right, at my vertex, so it doesn't go, in this case, above my vertex. So the highest I go is 1. So that's my highest, right, because I go bottom to top. So it tops out at 1. The bottom, it's going down forever, even if it doesn't look like it. So down forever to -infinity. Okay, so make sure you get your infinities right on those. All right, let's take a look at the next slide. So for this one right here, this one is where you have to do everything, right? You got to know everything about this graph. So we're going to just put it in standard form first. So f of x is the same as y. So I'm going to subtract 3. So instead of f of x, I'm going to go ahead and use the y. So subtract 3. And then -2 root x plus 4. So my vertex, I take -4 and +3. And then my stretch is -2. So my vertex and my stretch gives me my first 2 points. I'm going to do the graph down here. So I'm going to go left 4, and then up, oh shoot, I messed that up. I did go left 4, but I forgot to go up 3. So left 4, 1, 2, 3, 4, and then up 3, 1, 2, 3. So on the test there will actually be graph paper, so it'll be a lot easier than I feel like I'm just eyeballing right now. So then now I'm going to do my stretch, which is -2. So from my vertex, I'm going to go down 2 and over 1. And then to find my third point, I'm going to go 4 over from my vertex. So my vertex is at -4. And so I'm going to go 4 over. And so that's at 0. So that means I'm going to replace x with 0. So from here, I'm going to let x equal 0. So I will have, so I'm going from my original, so y equals 3 minus 2, replace x with 0. So 3 minus 2, and then 0 plus 4 is 4. So the square root of 4 is 2. So this will be 2 times 2, and then 3 minus 4. So when x is 0, my y value is -1. So get my graph. There we go. Okay, so there's my graph. So that's for part A. And then for part B, they want domain and range. So for my domain, I'm going to go from left to right. So here, the farthest left I go is according to my vertex, which is -4. And then forever to the right. So left to right. And then my range, bottom to top. So bottom, it looks like it's going down forever. And then how high does it go? So according to my vertex in the picture, it looks like it does not go above 3, right? So then my range, bottom, -infinity, and then it tops out at 3. So for part D, I want to know what is the open interval where f is decreasing. So don't be confused by the open piece. That just means use parentheses. So meaning we're not going to include a particular value, but we'll have a start. So decreasing, so this is always decreasing, right? So as I move from left to right, I'm going downhill. So it's always decreasing, but always decreasing on its domain. But we don't use it exactly like this because we're not going to include the -4. So it would be decreasing from -4 to infinity, open interval, meaning we're going to use parentheses. So if this function is decreasing, a radical function can't decrease and increase both. So then if it had asked for where is it increasing, we would just say never, right? Or nowhere. So it is always decreasing, never increasing for a negative radical. So now we want to know where is the interval, or the open interval, where f is negative and positive. So remember, our negative and positive always splits or separates at the x-intercept. So the x-intercept is a key piece of information in order to find where is my function negative, where is my function positive. So I didn't have to find the x-intercept in the earlier part of the problem, so that means I do need to find it now. And if I look at my graph, I'm like, oh, it looks like -2, but I don't know that for sure, right? Because I'm just kind of winging it when I connect my dots. So I can't trust that it's at -2, I need to solve that it's at -2. So I'm going to find my x-intercept. And in order to do that, I have to let y equal 0 and then solve. So I'm going to go from my vertex form right here, and I'm going to replace y with 0. Now I could do it from here, but it's usually a little easier, a little shorter right here. So I'm going to replace y with 0. And then solve from here. So 0 minus 3 is -3. And then I want to divide by -2 because it's actually multiplying to the radical. So then I have the square root of x plus 4, and then the two negatives cancel. And then to get rid of a square root, I want to square both sides. So then the square and the radical are inverses, so they cancel. And then when I square a fraction, I square the numerator, so 3 times 3. And the denominator 2 times 2. And then the last step is to subtract 4. Running out of room here. So 9/4 minus 4. Okay, so let's do, I'm going to do a little scratch work over here. So 9/4 minus 4 over 1. So in order to subtract two fractions, I have to have a common denominator. So I'm going to multiply the top and bottom by 4. So 16 over 4, and then subtract. So 9 minus 16, and then keep the denominators the same. Okay. So then now I have my x-intercept is at -7 over 4. So it was good that I didn't trust that it was -2. So if I want to figure out where is my function negative, where is it positive, I have to say when is it above and when is it below. So this part of the graph right here is above the x-axis, so this section is where it's positive. And then this part right here is where it's below, so that's where it's going to be negative. So if I look here, it starts at -4 and goes until I get to the x-intercept, which is at -7 over 4. So I am positive from -4 to my x-intercept. So -4 to my x-intercept. So -4 from my domain, -7 over 4 from my x-intercept. And then I dip below the x-axis, starting at the x-intercept, and then I stay below, so to infinity. Okay, so for my average rate of change, that's where I have to have my x and my y values. So this right here is my x1, and this is my x2. So the good news is I already figured out when x is 0, right? That was, we did that up here at the beginning. So that was my y-intercept. So I already know that when x was 0, my y value was -1. So now I have to do the same thing, but I'm going to replace x with 5. So I'm going to do what I did up here, but I'm going to use 5 instead of 0. So I'm looking up here. So So I have 3 minus 2, and then x plus 4, but x is 5. And then I want to simplify that. So we simplify the radical. 5 plus 4 is 9. And the square root of 9 is 3. So that will be 3 minus 6, which is negative 3. Okay, so I am going to use a piece of scratch paper here just to kind of finish this up. So for my average rate of change, I want to look at my ordered pairs here. So I have f of 0 equals negative 1 and f of 5 equals negative 3. So all I did was copy down those two answers there. So the formula is y2 minus y1. So I'm going to do negative 3 minus negative 1, and then x2 minus x1. So I'm subtracting my results, right? My output, my y values, and I'm subtracting my x. And it doesn't matter which way I subtract as long as I go the same way. And then a mistake students will make is when you're subtracting and you also have a negative, they'll tend to forget to put both negatives. So then I have a double negative, which is a positive. So then negative 3 plus 1 is negative 2, and 5 minus 0 is 5. Okay? And that's it for the average rate of change. So this was negative 2 over 5. Okay? All right. So this graphing one is similar, so I'll let you figure that one out. And let's go to the solving. So for the solving slide, I have 3 different styles here. And so let's just take a look at them so we recognize which one is which. So this is the one that's easiest to recognize because I have 2 radicals where these don't. So this one is the one where I can't isolate the radical, so I just square both sides. So I'm going to start with this one first. So this is a double radical, so I go straight to squaring. So I'm going to square both sides. And when I square the root, those are inverses, so I'm left with just the 5x minus 2. When I square here, though, I have to square the coefficient and the radical, right? I need to square both of those. So 2 squared is 4, and then root x squared is just x. So I have 5x minus 2 equals 4x. And so from here, I just want to solve for x. So I want to get my x terms together. I'll subtract 5x from both sides of the equation. That's 0. So I have negative 2. And then 4x minus 5x is negative 1x. And then divide by negative 1. So x would equal positive 2. Okay. And then between 1 and 3, they both have only 1 square root, but this has the extra x. So this one will end up being solved by factoring with an extraneous root, while this one will just be simple solving, so that'll be pretty nice. So let's go ahead and do number 1. So I'm going to do it over here, though, so I have enough room. So I'm going to subtract 1, though. I'm going to take advantage of this. So that cancels. And then 15 minus 1 is 14. So 2 ways I could do this is I could go ahead and square both sides, but I want to actually make the number smaller first. So to get rid of the 7, I'm going to divide by 7. And that's 2. And then now that the radical is isolated, I'm going to square both sides. And 2 squared is 4, and then add 5. And then let's take a look at question number 3. So similar to question number 1, I want to isolate the radical. So it already is for us, which is good. So I'm going to square both sides. So the inverse, square root, and square leave me just the x plus 2. And then here, when I have x minus 4 squared, I need to write it twice so I can use distributive property. So squared, meaning I have x minus 4 twice. And then in order to work through this, I need to distribute. So I'm going to multiply x to both of these and to the negative 4. And then I have to multiply negative 4 to both of these. So negative 4 and negative 4. Okay, combine like terms. So negative 4x and negative 4x. And then x plus 2 still. So then once I get to this stage, I have x squared in my problem, so that means I will need to solve by factoring. So in order to solve by factoring, it has to be equal to 0 before we can use the zero product property. So I'm going to subtract the x and the 2. And then I'm lining it up underneath the things I can combine it with. So this will end up being 0. Negative 8 and negative 1 is negative 9x, and 16 minus 2 is 14. So my factors of 14 are 2 and 7, 1 and 14. And then in order for it to be a negative 9, I'm going to use 2 and 7. And if both are negative, I'll still get my positive 14, but will get my negative 9. Okay, set each factor equal to 0. And then I need to check for extraneous roots. So what I know, as long as I solve correctly, the square root cannot equal a negative value. It could equal a positive, but not a negative value. So if I were to replace x with 2 up here, 2 minus 4 is negative 2. So this will be my extra or extraneous root. And then for x equaling 7, 7 minus 4 is positive 3. So this is my solution, and that's my extraneous solution. Let's do the next page. So for this one right here, this is not a question we can actually graph very well, so I'm only going to do part A on it. And then for part B, I'm going to go back and do question number 3 from the previous slide to show you how do we do it for graphically. So when I'm solving algebraically, I want to set f of x equal to g of x. So this is my f of x equal to g of x. And so for solving, this is just like the last one I did. So I want to isolate the radical, which it's already done, so I just need to square both sides. And when I square the root, those are inverses, so I'm left with just 3x minus 5. And then for this one here, I need to write it twice. And then distribute. So x multiplies to both of these, so x times x is x squared. X times negative 3 is negative 3x, and then multiply negative 3 to both. So negative 3 times x, and then negative 3 times negative 3. I can combine like terms. And then I have a quadratic, so I want to solve by factoring. So in order to do that, I need to have it equal to 0. So I will subtract the 3x and add the 5. That's 0. Negative 6 and negative 3 is negative 9, and 9 plus 5 is 14. So this is the same as the previous problem in terms of factors and stuff, so I didn't go over that part. And so just like in the previous problem, I would set each factor equal to 0. So when I do that, I will end up with x equals 7 and x equals 2. So when I replace x with 2, 2 minus 3 was the -1, so that ends up being my extra extraneous root. So x equals 7 is a true solution to this. Okay? All right, so again, we're going to do for part B, we're going to look at number 3 from the previous slide. So instead of using this up here, because this is not something very friendly to graph, we're going to do this problem instead. So when we want to find the solutions to the systems of equations graphically, we want to graph here. So I'm going to just put this into y equals form. And the -4 is not really with the x. And how do I know that? Because it's not grouped somehow. So there's not parentheses around it. There's nothing to indicate that it's really with the x. So I want to add it over to the y. And then I can find my vertex or start point. So for the vertex here, it would be -2. Nothing's being added, so 0. And then my stretch, or my a value, is the number in front, which is just 1. Over here, my start point, it's not really a vertex if it's a line. Nothing's being added to the x. And then for my y, it would be -4. And then my slope, which is really, I guess, a stretch as well, is a number multiplying x, which is 1. So then now I'm going to go ahead and graph. So my vertex is -2, 0. My stretch is 1, so I'm going to go up 1 over 1. To find my third point, I'm going to go 4 over, so 1, 2, 3, 4, so I'm at 2. So here y would equal, so I'm using 2 for x, so the square root of 4 is 2. So over to the 2 and up to 2. Then for here, I have a start of 0, -4, and then a slope of 1. So I could go up 1 over 1 forever, but I know that the ratio just has to be 4, so I'm actually going to go up 4 and then over 4 just to kind of make that a little easier. So I can keep going up 1 over 1, up 1 over 1, and so on, but we'll just go up 4 over 4. So the unfortunate part is I'm not on graph paper, so actually finding where they intersect is a little bit tougher. But if we were on graph paper, we could figure that out a little easier. So what I'm going to do is go one more value over just to kind of double check to make sure where the intersection is. So if I look here, I want to try to think of a value of x I can substitute in here that I know the root of. So if I put in, say, 5, for example, that gives me 7, and I don't know the square root of 7. If I put in 6, that gives me 8, still don't know its square root. If I put 7 in, that gives me 9, which I do know the square root of. So if x were 7, y is 3. So if I go over to 7, y is 3, so that would be right there. And again, so it would be easier again if I was on graph paper. So that gives me my solution to the graphs. And then in terms of the extraneous root, I know that I just need its reflection. And so if I did a reflection, my extraneous root would be right here. And if I had to guess, it looks like it's around 2. And if I go back and look at the previous slide, it would also tell me where it was. And I think it was, right? There was 7 was the solution and 2 is the extraneous. Okay? All right, last slide. So for this one right here, we're trying to just do the operations they're asking us to do. So for question number 1, they want us to add together f of x and g of x. So I just take my functions and I'm going to add them. So I'm adding radicals, I add the coefficient, and I leave the radical alone. For number 2, they want me to multiply. So I'm going to take my 2 functions and then I multiply 3 times 4. And then root x times root x. So if it's like radicals I'm multiplying, it's going to be just x, right? Root x squared or just x. So then my answer would be just 12x. And sometimes that confuses students, so when we're adding we keep the radicals the same, but when we're multiplying we change it. And refer back to your notes to figure that part out a little bit if that's still kind of confusing for you. Okay, so for this one right here, these are the composite functions here, and then we're doing a division one. So composite, remember, just when we're nesting functions, putting one function inside of the other. So I'm going to do a little rewrite here so we can see this better. So we can rewrite it like that. So all I did was put the g of x, which is on the right-hand side, inside the parentheses, and the one on the left goes on the outside. So this is telling me that I want to nest g of x into f of x, right? So whatever g of x is, I want to put it into f of x. So if I look here, this is my g of x, and they're saying to put it into f of x, meaning wherever I see an x, I want to replace it with x minus 1. So then wherever I see an x, replace it with x minus 1, right? Kick out the x and put in the x minus 1. And then from here I want to try to simplify. So if it's squared, I want to write it twice. Oops, almost wrote squared again. And then just carry down the plus 3. So I'm going to distribute, multiply the x to both of these, and the negative 1 to both of these, and carry down the plus 3. So combine like terms, so negative 1x and negative 1x, and 1 plus 3. And there it is, nested function. Okay, so let's take a look at number 2. So I'm doing a rewrite here. So the g, the left function, and then f of negative 3. So this one's a little bit different, right? Because I have a number I have to actually substitute in. So this is telling me I have to replace negative 3 in for my x values for f. So I'm going to go up to here. So I'm going to do this part first. So f of negative 3, so I'm replacing x with negative 3. So I have x squared plus 3, kick the x out, and put negative 3 in its stead. So that will be 9. So then I know f of negative 3 is equal to 12. Okay, so this now becomes my new input. So meaning instead of f of negative 3, it's the same as 12. So then my next action will be I want to find g of 12. So this is 12. So now I use the equation for g, and instead of x minus 1, I'm going to use 12. It will be 12 minus 1, which is 11. And that's my final answer. Okay? All right, last one, number 3. So here this is just dividing. So they want me to take h, which is this, over g, which is that. And then from here, I want to factor. So I think of factors of 5, which there's not a lot of choices there. How about 5 and 1? And I want to get a positive 4, so I want my 5 to be positive, and I'm still over x minus 1. And then because these are like factors, so like divided by like is 1, so this is equal to 1. Then all I have left is x plus 5 times 1, which is x plus 5. And that's the review.